Okay, so good morning everybody. Today we'll learn the principles of how to use a refractometer or how can we use refractometry in order to analyze the refractive index of a particular substance. Okay, so the first thing is, what do you understand by the word refraction of light? So we all know the refraction of light is an optical property which involves the bending of light or the change of the path of light when the light traverses from one medium to another medium. Right? So as I've studied in the lower classes, if a light passes from a rarer medium to a denser medium, like for example, air to water, what will happen? The path of the light will change. Why? Because the velocity by which the light will traverse from one medium to another medium, that will change. So this phenomenon is called refraction of light. Now moreover, in order to characterize the optical properties of a particular medium, we use the term called refractive index or RI. Okay, so refractive index is basically what? In very simple terms, suppose we consider an example where a light is traversing from air to water. So air is your first medium, right? And your water is the second medium. So if we consider the air as your VA, that there is the velocity of light in air as VA, and let's say VB is the velocity of light in water, then according to a law which is called Snell's law, that is VA by VB, that is the refractive index is basically the ratio of the speed of the light in vacuum or air to the speed of the light in the medium. And the refractive index for any medium is constant. Okay. So by this refractive index, we are able to understand the optical properties of a particular solution or of substance, depending on the whatever medium you are trying to consider. Now, the principle of this refractive index measurement is that whenever we are putting any sample, okay, so it will try to detect the bending of the light. So depending on the degree of the bending of the light, the refraction of light will automatically vary. Okay, that's why refractive index gives an understanding of the optical attributes, of the optical characteristics of a particular substance or solution. Okay, and the instrument by which we try to measure or we try to understand the refractive index of a particular solution or substance is called refractometer. Okay, it's called refractometer. Now the basic thing is that what is the principle of the refractometer? There is a prism that is lying inside the refractometer. Now the major important thing is that whenever we are placing in a solution, it is generally understood that the prism that is present in the refractometer, it has a higher refractive index than the particular solution. Okay, so what happens is that if we take a solution which has low amount of solutes or low concentration of solution, then automatically the prism's refractive index will be higher than that of the refractive index of the solution. So that means as the concentration of the solute, that is the substance in which you are dissolving, it increases, then the refractive index will automatically be high. Because the angle of refraction will be low. As you can see from the figure, if you can see from the particular figure in that part, the low concentration reading means the angle of refraction is higher. Now, as the angle of refraction decreases, so there will be a higher refractive index, which means that more amount of solutes are present, which contributes to the higher bending of light. That's why refractometers are very easy and a very wonderful tool in understanding the optical properties or the characteristics of any solution of particular substance. Now, the most important part, as our lab deals with food or food-like materials, especially in material science, so the most important thing is that we try to understand a term called Brix. So Brix actually indicates the grams of the pure cane sugar. Here it's written basically dissolved in 100 grams of pure water, which means it's basically gram of sugar per 100 gram of water. Okay, so Brix refers to the gram of sugar per 100 gram of water. Now, why we use this Brix measurement? Brix measurement is because we need to understand how much total dissolved solutes are present in a solution. Suppose we want to understand how much total solutes are present, so we represent that total solutes by the parameter called Brix, B-R-I-X, or percentage Brix or Brix, depending on whatever you want to measure. And digital refractometer is basically a what? The same principle is that, as I've explained. That one is the like what to say? It's an initial refractometer. With age, what happened? That like advancements have happened. So in digital refractometers, you can see that already the same principle is happening. We are applying the sample on a prism. So remember this, that whenever we are applying the sample, and when the sample comes in contact with the prism, then only the refractive index of the solution will be measured. Otherwise, we cannot measure that part. Okay. And here in this particular refractometer, in this particular setup, we have three types of modes. One is called the ND, which is for the measurement of refractive index. One is called the ND20, whenever we are trying to have a control, like whenever we are trying to control the temperature of the things, and then we are trying to measure the refractive index. And BRI is for the measurement of the percentage bricks. So there are three modes. Here in this practical, we will measure only the ND one. Okay. And there are lots of uses of the refractometer, especially in food and medical industries. Like for example, if you want to test like the urine sample, how much solutes are there in urine sample, or any kind of fruit juices. Suppose you want to measure the purity of a fruit juice. So this instrument is extremely important. Why? Because you can measure any type of purity or percentage purity in a sample using this refractometer instrument. And these are some of the precautions which I'll show you when we will move on to the practical. And the experiment we perform, I will automatically tell you how to perform the experiment. We will basically take solutions like standard solutions. We will first measure the refractive index one by one, and then we will try to find out the concentration of an unknown solution using the standard curve, which I'll explain you in the later part of the class. And this is basically a standard curve. Which what we do is, what is a standard curve? Standard curve means, suppose we already have known concentrations of solutions. Let's say we have 5 samples, A, B, C, D, E. We already know what are the concentrations. So standard curve is basically a curve, or we can say a plot, which helps us to determine the unknown concentration of any sample using the formula we all know, y equal to mx plus c, where m is the slope, c is the intercept, and x is the x-axis, y is the y-axis value. Okay. So depending on this, any plot, wherever you go in any practical, you will see that standard curve is a very important phenomenon. We will use that concept to measure the unknown concentration. Okay. So we'll proceed with the practical. Like instrument which is used to measure the refractive index, or we can say a refractometer. So you can see from here, this part, this is the prism where we will keep the sample. This is the screen where we will see the display. Okay, and these are 3 options which I'll show you one by one. So what we do is, before we measure the refractive index of a solution, we have to calibrate the instrument using distilled water. So what we will do, we'll simply switch it on. See, the on switch is here. So this is on. Okay, so 100% battery, bricks mode. So sometimes it's in bricks mode, so we have to convert it to the ND mode, or the refractive index mode. So what we will do is, here there are 3 options, read, 0 and range. So we will first click on range to convert it to ND, or the refractive index mode. Then what we will do, we will give a drop of distilled water exactly at the center of the prism. Okay, so that the sample comes in contact. So what we will do, we will simply, okay. So what we will do is, exactly we will place the center of this prism. Okay. And what we will do then, we will cover this with a cap that is placed at the back of the instrument. Why? In order to avoid any kind of interference of light. Okay. And then we'll go for 0. 0 means calibration. So the instrument gets calibrated. Okay. So after this, what we will do? We will do nothing. We will simply take out this particular water from this sample holder. Okay. and we will wipe it off with the tissue very gently and softly so that your finger stains does not touch the sample holder. So now what you do, let's take this solution which we will test basically today, and we simply take the solution with the help of a dropper, and we exactly place at the center again of the prism. Be very careful, only 1 to 2 drops is enough. Okay. Again, we cover this with a cap so that no kind of light interference occurs, and then we'll go for read. This time we'll go for read. You see that it's coming as 1.3342. As you can see, it's 1.34. That means the refractive index of the particular solution that we are trying to measure is 1.3342 ND. That is the refractive index. So by this way, we can measure the refractive index of any sample. So remember this, that every time we need to measure the refractive index of any solution, we have to calibrate first with distilled water. Then only we will be able to measure the solution. Otherwise, the reading will interfere. Okay. Simply again, what we will do, with the help of another dropper, we will take out, okay, and we will wipe off gently with a tissue paper. Okay. And this is,
don't rub it too much. Just put the tissue paper near to the solution. It will just soak it. Don't rub, otherwise the crystal will be damaged.
so in this way we can measure the ND. Also, you have other modes also. Depending on what you want to measure, you can take the other modes also.
Take both ND and ND20 readings.
Okay, so ND20 how we will do? I'll show you again another in the next part now. So we'll now switch it off because we have already done the part. So again we'll switch it off. Again we will go for the calibration at first. Switch it on. So here is ND mode already. So we have to put an ND mode. So what we will do? Range. So range is the option or the key by which we can change the mode of the refractometer. See, ND20. Okay, ND and ND20. Okay. So what we'll do? Again the same procedure. We'll take a dropper, take the distilled water, exactly at the center, only 2 to 3 drops, not more than that. Very slowly and carefully. Okay. And again, what we will do? The next step is to insert the cap here. It's placed at the bottom of the instrument. Here. Now what we will do? We will simply go for 0 at first. 0 is done. So again, we will remove with the help of a dropper. Here. Now we will simply wipe it off gently and very softly, not touching your fingers. And again, what we will do, we will take the same solution, whatever solution that we want to measure. Okay, the same thing. Now, we will again close the cap and then we will go for read. The same procedure. It's 1.3343. So we have got both ND and ND20. So today we will measure both the ND and the ND20 of the samples that we will provide to you. So the standard solutions will be given, and also each group will get an unknown sample. From that, I'll show you again after the experiment how to plot the standard curve and how to get the unknown concentration from the particular experiment. So we'll keep it off. That's it. how we'll plot the standard curve. So in order to plot the standard curve, open an Excel file, any Excel file that you open, and then what you do, in one column you write a sample concentration. That is, we have taken simple sugar samples, okay, of 1, 2, 3, 4 and 5% concentration. Now we will plot here the ND20 values. So we'll simply, I will just type it here as 1.3332. 1 minute, just the example. So you will do on your own, okay? So you values are plotted, right? So we have the sample values, the sample percentage, and their corresponding ND20 values. So what will you do is you simply select these two columns, okay? Go to insert, okay? Go to insert, and then you go to this option which is called the insert scatter, okay? Insert scatter plot. So scatter plot is a plot by which we can plot the standard curve of any sample or any experiment. So here we will go to the first option. See, you can see the standard curve like this. So ideally, an ideal standard curve should be always just a straight line. There are some experiments which will like encounter in your stage one, or like one by one, where there will be some outliers. Like it's like deviated from the straight line. So it should not be like that. But you cannot do anything because it's a part of experiment. So we have first given the standard curve. Now in order to get the line, what we will do, we'll go to this plus sign, okay, plus sign, and then we will one by one we'll go to the chart title, error bars you can give, but main thing is you have to go for the trend line. So first we'll go for this trend line. See, the line is coming. Now we will go to this option, okay, we'll go for linear. Why it's linear? Because it's a linear curve, y equal to mx plus c. So, and then we'll go for more options, okay. So here linear is there, you just scroll down, display equation on chart, and display R square value on chart. Now remember this is very important. R square value is extremely important to understand any curve value or any curve fitting. So for any curve fitting, the R square value is a statistical parameter by which you can understand whether the model that you're wanting to achieve is actually accurate or not, or it's good or not. See, the R square value is 0.9973. So if it's 0.98 or 0.99 and above, it means it's a very good standard curve. So we have got a very good standard curve. So I think we'll get like this itself. So we have got the equation. So y is equal to that 0.137x plus this one. This is the intercept. Now what we will do, so we have already got the standard curve. This is your standard curve. Now from the standard curve, in order to get the unknown concentration, we will use this particular equation. That is y equal to whatever is there in the things. So what we will do is, we will simply, let's say your unknown is any value. Let's say 1.3357. It's an unknown value. First what you have to do is, in Excel what you will do, y equal to this one. Y is what? The refractive index values. That is a NE20. And x is your concentration, right? So you will simply have to put find out x in terms of y. That means x equal to how much? Y minus that intercept divided by that 0.137. Simple equation. First you type it anywhere. So type it anywhere in your Excel. So x equal to bracket y minus 1.3319, okay, divided by 0.137. It's for reference. Now see, suppose in this column, so this is the column that we will have the value. So here suppose let's say the unknown value is 1.3359. Now this is a x, this is a value of y, okay. So what we will do is, we will have a formula, simple formula, equal to what we will do. See, bracket, I will give bracket this value, that is a y value, okay. 1 minute. Okay. This one, clear, minus 1.3319, okay, divided by 0.137. Then you press enter, the value will come. This is unknown concentration. So 0.02, or you can just multiply by 100. It's actually 2.9%. That's the concentration. So in this way, you can get any unknown values concentration from the standard plot. Any problem or any queries that you have? Okay, can you do it? So you like what you do, you go home and then you plot the standard curve and then you try to find out this equation, and if you have any problem you just come to me, I'll show you. Okay, and one more thing, I'll send you the practical, like the record, like what you have to write after discussing with the sir. Okay, you make sure that when you come to the next class, before that you complete all your practical, like files or whatever, write up, and then you come to the class. And one more thing, whenever you come to the class for the next class, you will have a lab test on this part. So be prepared. Okay, prepare yourself, whatever we have taught you. Beyond that also some things may come. Okay, so based on this, whatever you have learned today, you go home, you practice, and then you start your practical writing. Okay, and one more thing, assignment will be given to you today itself in the evening or in the night. Okay, you complete the assignment, make a lab copy, separate lab copy will go for lab assignment, and you have to submit on the day that you are coming for the practical. Okay, or you can submit beforehand also, depending on your availability. Okay, clear? Any queries or any questions or doubts I have? Anybody? So be clear about whatever experiments you are doing. From next time we will do more experiments. So that's why whatever doubts and queries you have, please clear at the class itself.